Assalamu alaikum dear student, this is Wajid Ali Shah and I welcome you back to the video session of chapter number 3, Electromagnetism. What is actually electromagnetism? Electromagnetism is a combination of two words, electro and magnetism. Electro is a word which is used for electricity or charge. Magnetism, it is for the magnetic effect of the magnet. So what is the word electromagnetism? Concept. Basically, in the previous chapter, we have discussed a concept of moving charge. So there are basically three effects of the current. A moving charge can produce three types of the effects, in which the first one is heating effect, another is magnetic effect, and the third one is a chemical effect. What is meant by heating effect? When a current is flowing in a wire, so the wire gets hot. It is because of the resistance of the wire. And that is actually, according to Joule's heating law, the lost energy of electricity is converted into heat energy finally. Another concept is magnetic effect. When a current is flowing, when a charge is moving in a wire, so additionally, along with the electric field, an additional magnetic field is generated around that wire in which some electric current is flowing. And the third one is chemical effect. When the current or a moving charge is passing through a liquid, it basically can produce ions in that liquid. So that is what we call the chemical effect of electric current. Today the topic is electromagnetism, the relation of electric current and magnetic effect. So we can define electromagnetism as the magnetic effect produced by electric current is called electromagnetism. It was for the first time discovered by Austin in 1820 in USA. He actually was experimenting on electric current, and during that experiment he discovered that when a wire which is carrying some current I, and we see that, for example, let us perform the same type of experiment here. We can also do it in physics lab. For example, this is a battery, positive, negative. This is a conducting wire which is passing through a cardboard, and this wire is again connected back to the negative of the battery. So, as we can see in the diagram, this is battery. We'll take, for simplicity, the conventional current direction. Let us we say that the current is starting from positive terminal of the battery moving towards the negative terminal of the battery. So, direction of the current through the cardboard is downward, like this. So, current is already there. We can also feel the heating effect of the current in this case. But the topic is magnetic effect of the electric current produced. So, as we know that magnetic field is an invisible field, and we must use some technique, some sort of tool to visualize the magnetic field. So we can take two things. One is called iron filling, iron powder, iron fillings. Another is magnetic compass. So let us we sprinkle some iron fillings, make iron powder on the cardboard randomly. What we actually do now, we want to visualize the magnetic field. So for that reason, we will slightly tape the cardboard. We will slightly touch or tape the cardboard. So after taping the cardboard, we can see that all the iron fillings are rearranged in proper circular paths like this. Now, why these circular rings, circular paths, circular rings? Iron fillings have been arranged in circular paths. Why? Because there is an invisible magnetic field around the wire, which we have visualized with the help of iron fillings. We can also do the same thing with the help of magnetic compass. When we stop the current, we can see that the iron fillings, the proper arrangement, the proper circles of the iron fillings have again disturbed. When again we touch the connector, the wire, we can see that the current is again started in the conductor and the circles have properly been arranged again. So this is basically an experiment to prove that there is an invisible magnetic field around a conducting wire whenever some current is passing through the wire. So this is what we call magnetic effect of this electric current, which is called electromagnetism. Electromagnetism is basically, we can also see some properties of the electric charge during its motion, which produces magnetic field. So, magnetic field is a vector field. Magnetic field is a vector field which must be having a proper direction and a magnitude. So, what are the properties of magnetic field? So, simply we can say that the properties of magnetic field depends upon the properties of current. For example, again I am going to draw the same diagram which I have drawn previously, like this: positive, negative. The first property is that the properties of the magnetic field are totally dependent upon the properties of the current. When the current is flowing down, direction of magnetic field is towards one side. If we want to reverse the current, like we make it negative and this one positive. So, direction of the current is reversed. We can see that direction of the magnetic field is again reversed. When we increase the magnitude of the current, we can increase the magnitude of the magnetic field. When we decrease the magnitude of the current, we can actually decrease the magnitude of the strength of magnetic field. So, as we have seen that magnetic field is a vector field, so what about the direction of the magnetic field? We can use right hand rule to find the direction of magnetic field produced by this current carrying conductor. For example, what is the statement of this right hand rule which is used to find the direction of the magnetic field around a current carrying wire? So, grasp the conductor by your fingers while keeping thumb in the direction of the current. Look at this diagram. For example, according to this diagram, the current is moving up. So we can grasp our fingers around this conducting wire and keeping the thumb in upward direction as the current is going up. So we can keep the thumb in upward direction. So the curling fingers will show the direction of the magnetic field. So according to this case, we can see that the magnetic field direction is what? Anti-clockwise. Like this. Look at the diagram. This direction can be found by right hand rule. If we reverse the direction of the current, like if we make this positive and make this one negative. This is a longer line, a shorter one, high potential, low potential. If, for example, this becomes high, this becomes low, so direction of the conventional current should be moving like this, and the direction of the current is down. Again, by the use of right hand rule, we can find direction of the magnetic field likewise, clockwise. So if we reverse direction of the current, we can reverse direction of the magnetic field. If we increase or decrease directions of the current, we can increase or decrease direction of the magnetic field. That's all. Thank you. Have a nice day.